Hello world, welcome to Ketrix channel. My name is Christian. This is the first of many videos we have planned to publish about software development, cloud architecture and cloud applications. In today's video, we are going to deploy a Docker application into a web server in just a few minutes. We wanted to start with this video since the main topics we are going to discuss in this channel are related somehow to containers. So why and how to create a web application with Docker? First of all, what is Docker? Well, Docker is a tool designed to make it easier to create, deploy, and run applications using containers. Why should you care about it? Well, if you take a look at websites like LinkedIn and Glassdoor, for what are most companies looking for in their developers' profiles, you will find out that Docker containers is a common topic. How to start with Docker? Well, in this channel, we will mainly work with Amazon Web Services. But in today's video, we will use a simple DigitalOcean droplet to deploy our first container. As we said before, for the purposes of this video, we are going to use DigitalOcean's droplets. They are simple to create, fast to deploy, and cheap. We are not associated with DigitalOcean, but if you create your account using the link given in the description below, you will get $50 in credit over 30 days. And for development purposes, I think that's pretty cool. What are the differences between virtual machines and containers? Here we have a picture that will help us find the differences. Docker uses OS-level virtualization to deliver your software in packages called containers. These packages include everything your software needs to run, like dependencies, libraries, binaries, and more. Containers are isolated from one another, so you can have multiple containers running software written in several different languages and communicating between them. Containers share the OS kernel instead of having a full copy of it. They take up less space and are faster to boot up than a virtual machine. You may be wondering who uses containers and where are they present. Amazon Web Services Lambdas functions are executed in container that isolates them from other functions. Microservices architecture was born to address the problem that people saw in a monolithic application, and containers are the natural way to deploy them. Companies are looking to become more agile so they can innovate and respond to change faster, and containers are helping their DevOps teams to address this. By the very nature of containers and Docker technology, developers can share their software and dependencies easily with the IT operations and production environments, while eliminating the typical "it works on my machine" excuse. One very important aspect of containers is how to orchestrate them. Here are some of the main orchestrator solutions available today. First of all, you have Kubernetes, which has become the leading orchestrator solution in the market. Amazon Web Services has its own orchestrator called ECS, and recently they launched their own Kubernetes service called EKS. And Docker has its own orchestration solution called Docker Swarm. How to start with Docker? To start developing with Docker locally, you should create your own account in Docker Hub, which is a repository for your images. Then you should install Docker in your machine. With that, you will have everything you need to run containers with Docker commands. Now we are going to deploy a Docker application to a web server. To follow our instructions, you will need to create your own DigitalOcean account, activate the two-factor authentication, add your SSH key, create a Docker ready droplet, and then you will have everything ready to connect to your droplet and run your first containerized application. Go to the DigitalOcean sign-in page. I strongly recommend you enable the two-factor authentication. This will make your account more secure. From here, we will be taken into the DigitalOcean console. Go to the security page. Here you will be able to enable your two-factor authentication or add your SSH keys. To add an SSH key, just click the Add SSH Key button. If you don't have one, you can create it with the instruction in the right side of the screen. Then paste the public key, give the key a name, and just click the Add SSH Key button. Now we have everything ready to create our first Docker-ready droplet. Go to the marketplace. Select the latest Docker image available for you. This image will be installed in the droplet we are going to create. For the purpose of this video, we are going to choose the standard droplet with 2 GB of memory. It only costs $10 a month and is charged per hour used. Choose the right data center region for you. Make sure your SSH key is selected so you will be able to connect to the droplet. Give the droplet a name and finally assign your droplet to one of your projects. The creation of the droplets will take a few minutes, but after that we will have everything ready to run our first containerized application. Now that we have our droplet ready, we need to connect to it through SSH. We copy the public IP given to our droplet. We SSH with the root user, which already has our public key configured to accept it. This will take just a few seconds. I strongly recommend you create another user so you don't use the root user. So you only need to add a new user, give it a password, and set the rest of the settings by default. Now we need to give sudo permissions to this user and also add it to the Docker group so it can run Docker commands. We will also create an application folder and give this user the ownership of that folder. We will change of user to connect with the new user created, and we are going to add our public key to the authorized keys of this user. Now we just need to paste our public key, save the file, change the permission of the file, restart our SSH server, and we are going to exit our session so we can connect with our newly created user. Once we are connected with our newly created user, we are going to create a folder that we are going to use with our container. We are going to run the following command. This command runs a container based in the Jupyter Data Science Notebook. It runs in a detached mode, it removes the container after it is stopped, it forwards a host port to the port where the container is running the application, it names the container Jupyter, it mounts the folder we just created into the container so we can persist the data. Once the container is ready, we need to get the token to connect to the Jupyter Notebook. So we just run this command, get the droplet IP, and paste the token with the port at the end of the IP. We have successfully deployed a Jupyter Notebook containerized application in our web server. We are going to use this container to create new videos. Thanks for watching. If you have any comment, please leave it in the comment section, and I will be glad to respond as soon as possible. See you next time.